Welcome to this video of physics where I'm going to teach you acceleration and velocity in 1D motion. But we need to know what is physics before getting involved into things that you guys don't even know. Well, physics, when you think of physics, think of rules that are being applied. And you have to know that rules are applied because you have to know the rules to solve a problem. You see, you need to know some kind of information to solve a problem. You can't just have one information and get hundreds of answers. Well, that's not true. Well, let me get to this part later on. Now, for this video, let me talk you about velocity and acceleration in 1D motion. You know that our world is not consisting of 1D motion. It has more than 1D. Like if a rocket was launched from a launch pad, it will go up, and then when it lands, it goes up and down. So you see, that's 1D motion. Or if there was a car, it goes forward, and then when the car reverses, it goes backward. So you see, there's 1D motion applied. So let's talk about that first, okay, 1D motion. Now, I know that there's more than 1D motion. Our world does not consist of 1D motion, but let's get started with 1D motion, because every physics lecture, you see, starts with the basic fundamental of physics, okay? So, let's talk about velocity. What is velocity? I hope you guys are writing this down while I'm saying it. Velocity is a quantity of a magnitude and direction. When you have magnitude, you know amount of something. Like in this room, there's some amount of air, oxygen. That is the reason why I can breathe, right? But I don't know where it is, so I don't know the direction, okay? So, but I know they're moving somewhere, okay? So, when you have, that's called the magnitude, okay? The amount of something or size of something, that's magnitude, okay? The direction is moving, well, if you know that if you have a magnitude, and if you know the direction, it is said that you also know it is a vector. Velocity has magnitude and direction, so we can say velocity is a vector. Okay? So, let's go ahead and solve problems using this kind of information, but I want you guys to know about displacement, distance. Now if you haven't heard of the word displacement, don't worry about it, because I'm going to teach you guys what is displacement and distance at the moment. If you know displacement, you should know that displacement is very, very similar to distance. Let's say that you were at Arizona Mall, okay? This is Arizona Mall. Arizona Mills Mall, okay? Was located right here. Okay, and if you had to go to Fry's grocery shop, which is over here, Fry's, okay? So if you had to go by the roads, okay, you would travel some distance. That is why if you travel by car, you would say, when you reach to Fry's, you would say, hey, I traveled distance of 6 miles, 2 miles, 3 miles, but you remember the keyword, I traveled the distance, okay? You don't say displacement, because I'm going to tell you guys why don't you say displacement. So you you start with coming over here by roads, and finally you reach at Fry's. Well, if you were to walk this kind of pathway, you'd get tired, don't you? You see, you have long distance to travel, but if you have a displacement, which I know most of the kids like because they get lazy often. So if you for the people who are lazy to do mom's work, this would be a better explanation for you. Think of displacement. So if you don't want to travel that much distance, okay, it turns out that you can travel displacement, okay. So displacement is the straight pathway between 2 points. So let me take straight line. Okay, so displacement is always less than distance. So if you were wise enough, you would cut the roads, like go middle of trees, go from the gardens and things like that. You just cut stuff up. Like you wouldn't travel by roads or pathways. You would just cut and just slim your way through the fries, you see. Another example I want you guys to know is that if you lived in Saudi Arabia and if you lived in Camp 7, which is over here, and if you had to go to Dira market, now it's the same as Fry's grocery store but different names, okay, because it's a different country, okay, and it's Dira market. What is the wise way to travel? Well, after the first explanation, you might guess that the wise way to travel is displacement, okay? But in some cases, like over here, okay, in some cases, the displacement, let me just indicate displacement. To be d and distance to be small d. So if I have small d, it's distance, and if I have big D, capital D, it's displacement. That means I'm talking about displacement, okay? So in some cases, like this one, okay, sometimes D is equal to small d, which means displacement is sometimes equal to distance, okay, but it also is that d is never less than distance. I mean greater than distance. So it's never more, it could be equal, or let me just rephrase this. It could be less than or equal to distance. Okay? So this is the main thing, important thing that you should remember. If you remember this, you know that this is true, that distance is never less than displacement, because it's distance is going through roads and displacement isn't. Because displacement, you're just cutting your way through that because you want to reach at some point early, okay? You want to just go there and take stuff from the groceries, like your mom told you, hey, Paolo, if your name is Paolo, okay? Hey, Paolo, go buy me a soda. So you're playing a game. Well, I hope you're tired to go there. You're like, no, mom, and so on. But what you should do is, if you live over here and suppose this was your house, and this was your house. And suppose this is a grocery market, and Dira market is a grocery market, okay? And this is your house, so you wouldn't want you to travel distance, okay, in a pathway, okay? So you would go by displacement, cutting your way through houses, jumping over the fences to reach to the point faster, okay? Because you are traveling a straight path. But also remember, displacement is always straight. If the displacement was right here and going like this, because of this, it's not displacement, okay? It's not displacement because of that. So let me involve quotients for displacement as we have saw. Now if you don't know something, don't say, hey Karan, you never taught us, because I am going to teach you while I'm explaining. So don't be shocked out, okay? So if you had a park right here, or let's say a water right here, water and water right here. Now this, both water or pound has some kind of displacement, okay? Let's represent this distance with x, okay? So if you want to know how far we have traveled from this one to this one, or from this one to this one, we have change in x. I'm going to teach you what it is. Was xf minus xi. What it means is, this is a sign of delta, okay? This is a sign of delta. Delta basically means that change in something, okay? If there is a change in something, there is delta in something. So change in x is equal to final distance minus initial distance, okay? You would never do initial minus final distance, because then you would end up in negative distance, and distance is never negative, okay? So if your teachers asked this, that what is change in distance, if this was located at 8 and this was located at 15 on the number scale, okay? Like if you don't know the number scale, like 1, 2, 3 and so on. Okay, so it was located at 8 units, and if this was located in 15, what would you do? Well, you're going starting from here to here, okay? So if you were starting from here to here, you would do final. This is your final point you were trying to, and this is your initial point where you're starting at. So final minus initial, which is final is 15. 15 minus 8, change in distance is you get to be 7. So there are 7 units that you have been traveling, and that is the displacement, because it's a straight line. It's not going up and down or side by side. Okay, now let's go back with the velocity, and in this topic I'm going to teach you what is velocity, displacement, distance, which I already did, and I hope that you have understood all the concept, because my goal is to make you guys succeed in your test given by your teacher, okay? And let me just draw a graph which represents a car. Okay, if this was a graph and this is x-axis and this is y-axis. Okay, if this was a graph, car is starting from the origin like this, and then it's going there. So you see, from the origin to the highest maximum point, it's going forward at the highest speed it can. So let me mark the point so you guys can see. From this point, which is origin 0, 0, it's going to the highest point located here. It's speeding up, okay? So we can represent this point by M and this point by 0, okay? Or O. So from O to M, the car is speeding up. Speed up. So the car is speeding up. But from M to, let's indicate this point as N. From M to N, what is it doing? Well, it's slowing down. Slow down. Okay, so it's the velocity. Now, how would you figure out that? If you were to sit in a car and you know the speedometer is the arrows of speedometer is going up, down. When it's going up, the driver is increasing the velocity of the car. But when it's decelerating, don't get confused the vocabularies. When it's decelerating, when the arrow is going down, the driver is decreasing the velocity. So for instance, the driver in this car, let me draw the car so you guys know which car is it. The car is this one. Okay. No, I never said I was an artist. But if this was a car, and this is a car though. So if this is a car moving at some point, and let's say it's traveling at 20 meter per second. And meter per second is a unit, the unit of velocity. I'm going to represent velocity as V. The unit of velocity is meter per second. Okay, so it was traveling at 20 meter per second and then it slowed down and it went back at 10 meter per second. That is all that is saying, okay. So, knowing these things, let us solve example of velocity. Now, for some of you guys, this stuff may be easy, and I hope that you learned it well enough that you can get exceeds on your test or exam or pop quiz is the main. The question will appear on the screen as well after I read the question. The question is, Spider-Man is running to catch his enemy. The time it takes to reach his enemy is 3 hours. Let us note that thing down. The time it takes to Spider-Man to catch his enemies are 3 hours, 3 minutes, and 10 seconds. Okay? And he finds out that he traveled 10 miles, 500 yards, and he finds out that he traveled 10 miles and 500 yards. So knowing this information, we need to find what is the average velocity of it, okay? So the distance he knows that he traveled is distance. He knows that he traveled is 10 miles and 500 yards. Like I told you before, velocity is always replaced. The SI unit of velocity is meter per second, but only for this example, I'm going to make the velocity in miles per hour, because the question says what is the average velocity in miles per hour. If it were to say what is the velocity in meter per second, then we have to convert it into meter per second, but it doesn't. Okay, so average velocity, you may see that. Now here's how we write. There's a specific symbol for average velocity, and here's how we write it. We write V, which we know is velocity, and we write a dash over it, which means average velocity. Okay, so average velocity is change in distance over change in time. Okay, now change in time is equal to final time minus initial time, and change in distance is final distance minus initial distance. Okay, but we're finding the total time. Okay, so the total time here and total distance here and total time here. So there's both ways we can write it. Either we can subtract this if the information were a little bit different. Okay, we have to add in this case and add the time here, because we don't know the initial time, it just gives us the time, and we don't know the final distance, it just gives us the distance. That is the reason we add it. That's why we say average velocity is equal to total distance over total time. So if let's convert. Now we want miles per hour. You see, we have hour here, so that is perfectly fine. Okay, now we need to convert 3 minutes into hour. So 3 minutes, and here's how we do it, conversion. Okay, and this is the best way I learned it. So 3 minutes is is known to be 60 minutes in 1 hour. Alright, minutes cancels out, and if you were to calculate this in your calculator, you'd get 0.050 hours, because you end up in hours. Now we take 10 seconds, you know that 60 seconds make 1 minute, and 60 minutes make 1 hour. Okay, if you were to calculate that, you would get 0.0028 hours. Now we simply add the time here. Okay, let me erase it and add all the time. The time it took is 3.0528. Okay, now we need to find distance. Well, it says miles per hour, so 10 miles is perfectly fine. Now the problem here is we have yards. Now how would you do yards conversion? Well, you have 500 yards. Now yards is YD, and then you have 1 yard to be 3 feet, right? Now it's just something you can look it up on internet. Okay, and 280 feet is in 1 mile. Okay, and if you do that calculation, you would get 0.284091 miles. And the total distance we found here is 10.284091. If we add this to 10 miles. Okay, now look back at the equation I told you. Average velocity is total distance over total time. So the total distance we found is total distance, TD, total distance, is equal to 10.2840. Okay, 10.84091 divided by the total time, which is 3.0528, and this is miles because it's distance, and this is hour. Now the average velocity turns out to be 3.36871 miles per hour. So the average velocity of Spider-Man was 3.36874 miles per hour. Now we have one more example of velocity. The question is, it should be showing on your screen. The question is, Ricky is a person, okay? Don't get confused. It's a person's name. Ricky is pushing his dirt bike, so he's pushing his dirt bike as the fuel was low. Because the fuel was low, he was pushing the bike. Okay, it took him 1 hour, 90 seconds to go to the gas station. Okay, he knew that he traveled 2 yards every second. Okay, how much distance did he cover during the time period? So we know that time is given. Time is 1 hour, 90 seconds. Okay, and the velocity is given to be, he says 2 yards every second. Okay, now we need to find the distance. Well, we know the equation to be average velocity is total distance over total time. Okay, so how many seconds are there in this time? 1 hour. Okay, so we need to find how many seconds are there in this. Okay, we need to find the distance, so we do times time times time, so we get times velocity is equal to distance. Okay, and 2 yards, we convert it in the conversion factor. It's 1 yard, 3 feet, and 5280 feet. You cancel feet with yard, and then you have 1 mile. Now here again we are representing our answer in miles per hour. Okay, so you have 0.001136. Okay, and then you convert 90. Okay, let me just use another marker here since it's getting blue all over the place. Okay, then you convert the time, which is 90 seconds, into hour. Okay, and you know that 60 seconds is 1 minute, seconds cancel out, 60 minutes is in 1 hour, minute cancels out, you'd get 0.025. So you have the time, you add it to 1, and you have the velocity over here. So all you do is add this to 1 hour and you multiply that one. Okay, so if you add all the things, this is the final version you should be getting. If you add 0.2500 times 0.001136, okay, you should be getting 2.84 times 10 raised to -5. Okay, and that's miles per hour. Okay, that is the distance he traveled. Okay, so that is in miles. This distance is in miles. Okay, but we can do an extra step and make the answer in yards. Okay, so if you convert this in a simplest form, you should be getting to be 0.019136 yards. Okay, YD. Okay, So this is the answer, that the distance he traveled. Distance that Vicky traveled.